Naming acids and bases. All right, let's start off with bases. They're more simple. Bases, for our purposes at this time, are going to be considered compounds that have hydroxide ions. Producing hydroxide ions in water is the basic definition, and it means it's alkaline or it has a pH above 7. Falls into the base category. And hydroxide, of course, is OH minus. And they're just going to name them like you would name any regular ionic compound that has a polyatomic in it. So it wouldn't be any different than what we were just doing in the warm-up. But let's go ahead and do these examples real quick. What's Ba again? How would we name this? What's Ba? Say it's over to the left, down below on the table. Barium, very good. So this is barium. Does barium need a Roman numeral? Nope. And OH, of course, is hydroxide. So barium hydroxide. Pretty easy. Now here, KOH. What's K? Potassium. And does potassium need a Roman numeral? No. So it's potassium hydroxide. Last but not least here, Cr. What's Cr? Chromium. Does chromium need a Roman numeral? Yes, chromium is in the transition metals section, so we do need to figure out the Roman numeral. It's not zinc, silver, cadmium, which are exceptions. So yes, this one's going to require a Roman numeral. Now, we know hydroxides are -1s, and there's 3 of them here, so that's -3. So in order to add up to 0 now, what must be the charge on the chromium? It must be +3. Very good. So our Roman numeral here is going to be a 3, and then you would just write hydroxide. So it's just the same as writing stuff that you would for regular ionic compounds. There are the answers too, in case you need to go back and recall them. Now, acids. This one's the tricky system. This one's different. They are compounds that release hydrogen ions in water, H pluses. And hydrogen ions are always H plus because the hydrogen loses the 1 electron that it has, and therefore it's always H plus. The cation's always H plus, or hydrogen ion. And we look at the anion to name them. Whatever the anion is, that's going to be the system that we look at for naming our acids. Now, before we get to naming them, I want to look at how you write the formulas and determine the number of hydrogens to use. So here's an example. This one's called oxalic acid. And oxalate is one of your polyatomic ions. It's C2O4 - 2, oxalate. And of course, if we're writing the formula, it's going to combine with hydrogen, which is +1. This is -2. So how many hydrogens do we need to balance this out and make it equal 0? We need 2, exactly. So this would be the formula. And now it's a simple way to do. Look at the charge on the anion, which is -2. That number, the number in the charge becomes the subscript on the hydrogen. Okay, the number on the charge becomes the subscript on the hydrogen. Let's look at one more example. Hydronitric acid. The ions are hydrogen, which is H plus, and nitride, which is N3-. How many hydrogens would you need here to balance out that charge to make it add up to 0? 3, good. So it'd be H3N. That means the number 3 there in the charge becomes the subscript on the hydrogen. So that's an easy system of how to do that for finding the formula of the acid. Now let's talk about the name. We have a nice little mnemonic for this. So for binary acids that have no hydrogen, we're going to use the prefix hydro and then the root of the anion's name plus ic acid. So hydro something ic acid. Now if it doesn't have oxygen, it's going to be like this, one off the periodic table, like Cl minus, Br minus, S minus 2, stuff like that. No oxygen in it, so it's really a monatomic anion for the most part, with few exceptions to that. So the anion name here happens to be chloride. When we combine the two, remember this is going to combine with an H+, so it's one of each to make it add up to 0. We get HCl. This is where the name comes into place, and this is your root, chlor. So it's going to be hydrochloric acid. Hydrochloric. Hydro in front, the root name, ic acid. Now we have a mnemonic to help you remember this. My ride, IDE, if it's IDE, has hydraulics. Hydroic. Hydraulics, hydroic. My ride has hydraulics. All right, let's look at the next one. Tertiary acids are ones that contain oxygen, so these are going to be your polyatomic for the most part. If the polyatomic anion ends with 8, ATE, 8s, you just change the ending to ic. So if we're looking here, this is sulfate, SO4 minus 2. Remember, if we're adding it to H pluses, what would our formula be for our acid then? In order to make the one with the sulfate, make it an acid. How many hydrogens do you need? 2. Good. The charge on here is 2, so that means you need 2 hydrogens. So this one's going to be H2SO4. Now this is where it gets a little strange, especially for sulfur and for phosphorus. Whereas before we would drop a lot of the name at the end, like we didn't call it sulfuride, we called it sulfide. Well, you're going to keep the fur in this time. So all we do is change the 8 to ic. This is going to be sulfuric acid. And same thing with if you have phosphorus. We don't go phosphic acid, we say phosphoric. They don't drop the whole ending like they did on the other one. So phosphoric, sulfuric, those are the two that are a little tricky because they don't drop the entire name like you're used to doing. The mnemonic for this one is I ate something icky. So if it ends in 8, change it to ic. If it ends in 8, change it to ic. The last one, if it has ITE, it's an ite. It goes to OUS. And of course, SO3 minus 2, because it has 1 oxygen less, that means it's going to be sulfite. And of course, if we combine sulfite with our charge here, with our acid, our H+, we know we're going to need 2 H's. So this would be H2SO3 for the formula. To balance out the charge, you need 2 pluses plus the minus 2 here. But the ite now is going to change to OUS. So instead of being sulfuric, this is going to be sulfurous acid. OUS. So the mnemonic that I go with this one is Sprite is delicious. Ite, OUS. Sprite is delicious. How to change the endings on the names there. So, lots to absorb here with the acids, definitely a different type of naming. But let's do some practice. Let's look at the first one right here. With the name, and we're going to go to the formula. Nitric. What does the ic tell me about the anion? Is it ide, is it ate, or is it ite? It's 8. So this is from nitrate. What is nitrate? What is the formula for nitrate? And the charge. Don't forget the charge. What's the formula and charge of nitrate? Yes, it's NO3 with a -1. Now, to combine it to do the formula, remember it's always an H+. So how many of each do we need to write the formula? How many H's, how many nitrates? 1 to 1, yes. So it's just going to be HNO3. This would be the formula for nitric acid. All right, let's look at, say, hypochlorous acid. What does the OUS tell us? What am I looking for? I, 8, or ite? I'm looking for ite. So really, I need to go to my table of polyatomics and look for hypochlorite. Hypochlorite. What is the formula in charge of hypochlorite? It is ClO-. Exactly right. Now, if I combine that with 1H+, what's my ratio here and how would I write the formula? How many of each one do I need? This is +1, this is -1. How many of each do I need? To write the formula? Should be what? HClO. One of each, yes. One of each in the compound. All right, let's look at one more here. Like Hydrobromic Acid. What does hydroic tell me about what I'm dealing with? 8, ite, or ide. No oxygen, so this is just Br. And what ion does Br form? What's its charge normally? Off the periodic table, of course. Yes, it's -1. So if I'm doing this one, 1H, 1Br, that adds up to 0, so this would be HBr. One more here on this side before I go over to the other side. Let's look at carbonic acid. What does the ick tell you? What am I looking for? I'm looking for 8, so I'm looking for carbonate. What is carbonate? I need the formula and charge. I need to figure that part out. What is carbonate? I'll tell you it's a CO something, CO3, and the charge is -2. Good. Now in this case, when I combine it with H, how many H's do I need for that formula? I need 2, right? So this one's going to be H2CO3 because I need 2 pluses to get, 2 of these. So that's 2 plus, 2 minus, and that equals 0. Don't forget, we're always trying to add it up to 0 with the charges. All right, so those are some examples of how to write the formula from the name. Let's go over here to the right and look at the formulas. The names to the formulas. We're going over here to do formulas to names. All right, so here, let's do this one. H3PO3. I need to go find PO3. What is PO3? Is it an ide, an 8, or an ite? It is ite. Very good. This is phosphite, by the way. Okay. PO3 minus 3 is phosphite. So, what do I do to the ite ending? What do I change it to? Is it hydroic, ic, or OUS? Yes, it's OUS. So this would be phosphorus acid. Phosphorus acid. Let's do another one like this one, MnO4. That's obviously a polyatomic. What's MnO4? What's its name? I'll write it over here. Anybody find it on the polyatomic chart yet? MnO4. Permanganate. Very good. Manganate. Good. It's an ATE ending, so what do I change it to? Ic. Yeah. So this becomes, oops, sorry, my pen. Back. Okay, this becomes this ic. All right, so we change this to permanganic acid. It's a mouthful to say. Permanganic acid. Hi is always my favorite. Here, I'm going to do it over here, though. Hi, HI. Hello. What does this tell me? What does I tell me? What are we dealing with here? Ite, ate, or ide? It's an ide. Good. So for ide, I need to put hydro, something, and then ic, and acid, right? Now this is where this one gets fun too. This is hydroiodic. Actually, I didn't need all that space there. That's how you say it, hydroiodic acid. So that would be for hi, HI. You get to say hello. Well, now it's 1:21, so we have to stop for today, but you can check out and do more examples. The answers are on the next slide.